Good day, I'm Maile Matsiba. Welcome back to our channel. Today we're going to be looking at example 2.7.4. We're continuing with our section 2 of the 2017 study guide. The question says a liquid of density 1630 kilograms per meter cubed must be prepared by mixing clay with water. How much clay, which has an SG of 2.1, must be added to 100 kilograms of water to achieve the required density? Now in the first two steps, I try to just put together the densities of both the liquid and the clay. So with the first one, I converted the 1630 kilograms per meter cubed into kilograms per liter, and that gave me 1.630 kilograms per liter. Now also the density of clay, since the SG is 2.1, that means it's 2.1 kilograms per liter. Now when we have this information, the next thing we need to do now is to actually choose a basis, and we're going to be using a basis of 100 kilograms water. This is because we have already been given that the water is 100 kilograms, so that is what we're going to move in. Now with this said, this is going to be a little bit more mathematical, but it's not so difficult, so as it's going to be pretty much simple arithmetic. So with the information we have, the densities and also the water as 100 kilograms, we're going to say that let x be the mass of clay. Remember the question said how much clay must be added to the 100 kilograms of water to achieve the required density. So we actually want to know how much clay, so we say let x be the mass of the clay added. And not only that, another important thing that we needed to calculate is the volume of the clay. So we also going to say and y be the volume of the clay added. So yeah, we're going to actually be constructing equations out of the information that we have. We have our x, which is the mass of the clay, and then we have our y, which is the volume of the clay. Now with that said, we're going to be using our mathematical background to actually establish the equations. But before we go there, another thing I wanted also to calculate, since now we're going to be having the volume of the clay as y, from the information we can actually calculate the volume of the water, and that gives us the volume of the water is equals to the mass of the water all over the density of the water. That becomes 100 kilograms all over 1 kilograms per liter. Now that gives us 100 liters. Can I just write here that density of water is equals to 1 kilograms per liter. So we have the volume of the water, and now it's time that we actually establish equations out of that, and we're going to be using the equation of density for the mixture. So we will say density excuse my handwriting please, density of the mixture is equals to the mass of the mixture all over the volume of the mixture. Yeah, so the density of the mixture is going to be the mass of the mixture over the volume of the mixture. Now that equals to the mass of the mixture is 100 kilograms of the water, and also the x, which is the mass of the clay that has been added. So our mass is going to be 100 plus x, and they are all in kilograms. Now our volume is also the volume of the water, since we calculated from the mass and the density, and also y, which is the volume of the clay. So it's going to be 100 plus y. So now, but we already know that our density is actually, we have been given as 1630, and then we calculated it in kilograms per liter as 1.630. So we know that this is 1.630, and that becomes our first equation. Now our second equation, we're going to be saying that we're now going to be using the Hg of the clay. We know that the density of clay equals to the mass of the clay all over the volume of the clay. Now the density of the clay, we know it as 2.1 kilograms per liter is equals to the mass of the clay is x, and the volume of the clay is y. Now this becomes our second equation. Now with that said, we're going to now be solving two equations like simultaneously. So we can just say from 2, this is the good old high school technique, from equation 2, x is equals to 2.1 y. Now this becomes our third equation. Let me just put off this page and get a new one as we continue. Now we already know that our x is equals to 2.1 y. It's our third equation. Now as we continue, we say substitute 3 in 1. So we're going to be substituting this equation into this equation. Now that gives us 1.630 equals to 100 plus 2.1y, sorry about that, all over 100 plus y. That is actually when we reach this stage, what we need now is only simplification. And if you do simplify it, then okay, let me just put it here. Let me just simplify it a little bit more, and then when you simplify, you get that. I just multiplied it by this all through, and then in this side it cancelled, in this side it multiplied. And now when you calculate your y, you find that, or as you go on simplifying, you find that 63.0 equals to 0.47y. And then our y equals to 134.043. Therefore, our volume of clay added is equals to 134.043 liters. So yeah, that is actually our y that we solved. Now as we move further, then we're going to be saying, let me just bring back this one. Now that we have the y, we say This is actually our third equation. We can say from 3 x is equals to 2.1 multiplied by 134.043, and that becomes, the answer becomes, let me just verify here, it becomes 281.490, right? That is our x. Therefore, mass of clay is actually equals to, or let me say, sorry about that, let me say mass of clay added. Let me just be more specific. Mass of clay added is equals to 281.490 kilograms. So yeah, that is it. And remember the question was saying that how much clay must be added to 100 kilograms, how much clay must be added to 100 kilograms of water for us to achieve that density. And this is actually how much clay must be added, 281.490 kilograms. And also, this is actually the volume of the clay. So either way, whether one can present it in the volume or in the mass, I think it shouldn't really be much of a difference. So this is actually our example 2.7.4. So thank you for your time. I hope we meet again on our next video.